Hey guys, Mr. Milton here. Today we're going to talk about conditionals and converses. At the end of this video, you should be able to identify a conditional as well as its parts. You should be able to write a converse from a conditional, and you should be able to determine the truth value of a conditional and provide counterexamples when necessary. Alright, last lesson we looked at inductive reasoning. The next couple of lessons we'll look at deductive reasoning. Deductive reasoning. Okay, and remember that deductive reasoning goes from general to specific. Okay, big part of deductive reasoning is conditional statements, and this is one that can be written as an if-then form. Okay, it has two parts: the hypothesis and the conclusion. Okay, the hypothesis is the if part, the conclusion is the then part. Okay, and so here's an example of some type of question you might be asked. It says, identify the hypothesis and the conclusion of the conditional statement. If I eat fast food, then I am unhealthy. The hypothesis would be, I eat fast food. Okay, the part that follows the if, but is also before the then. The conclusion would be, I am unhealthy. Okay, notice that the hypothesis does not include the word if, and the conclusion does not include the word then. Okay, so not necessarily that this is a true statement. This is just a conditional statement. It says, if I eat fast food, then I am unhealthy. Okay, notice conditionals have a truth value. Okay, they are either true or false. So truth value is just another way to say that they're either true or false. To show a conditional is false, you need to provide one counterexample. Again, pretty straightforward word there. An example that's counter to what's been said. Okay. A counterexample is an instance when the hypothesis is true, but the conclusion is false. Okay, so for example, you might say, I eat fast food, but it's usually a reward for working out all week. Okay, or working out 4 times this week. So eating fast food is not the conclusion that I am unhealthy. Okay. Okay. So all you have to do is prove one example, provide one counterexample to show that a conditional is false. Okay, I'll ask you to provide the counterexample for this first problem and bring that in complete with your notes. Okay, as we go through a few more examples together. So, in the bottom of the page we have the directions to provide a counterexample for the following conditional. If the absolute value of x is greater than 0, then x is greater than 0. Well, what do we know about absolute values? That absolute value is always greater than, well, the absolute value of a negative number will always be greater than 0. So our counterexample here could be that x equals negative 1. If x is negative 1, then we see the absolute value of negative 1 would be 1. Okay, which is greater than 0. Shows that the hypothesis is true. But then the conclusion would be that negative 1 is greater than 0. So if we plug this in here. We say the absolute value of -1 is greater than 0 because it's true. It's 1 is greater than 0. That's the hypothesis. It's true. Okay. Then we say -1 is greater than 0. Well, that's false. Okay, so again, our counterexample is a situation where the hypothesis is true and then the conclusion is false. Okay. Really quick, I don't know if I've spent enough time showing you this, but symbolically, if you take a logic course, which a lot of people will have to take in college, you might just run across this anyway. P is the symbol for hypothesis, and Q is the symbol for conclusions. Okay, a lot of times when people say check your P's and Q's, people think that it means like that you wrote everything in the right direction, but it's check your logic. Okay, this is hypothesis and conclusions. Make sure that what you're thinking goes to, or what your hypothesis leads to your conclusions before you're done. Okay, so P's hypothesis, Q's conclusion. Symbolically, if we're talking about a conditional statement, we'll say P arrow Q. P leads to Q. Hypothesis leads to conclusion. Alright, and we'll use that a few times through this chapter. Alright, so now let's try to write a conditional statement based off of given statements. So here's a given statement. It says an acute angle measures less than 90 degrees. Okay, this is just a statement of fact. And so what we're going to try to do is from the statement of fact is write a conditional statement. Okay, and that's an if-then statement. And so I'll start and say if an angle measures less than 90 degrees, should have used mathematical symbols. Okay, then it's acute. Or I could say then it's an acute angle. Okay, notice that this does follow the pattern of a conditional statement. It's an if-then statement. Okay, and that's it. Okay, Venn diagrams can also be used to illustrate a conditional statement, and so we're given this Venn diagram here, and they want us to write a conditional statement based off of the Venn diagram. Okay, and I know that you're used to seeing Venn diagrams like this thing with the overlapping thing, and the comparison typically is what's A, what's B, what does A, B have in common, and you can still do that sometimes. In this case, this is a Venn diagram as well. Notice we have athletes and then Olympians, so it's basically, if we just look at like one thing, looking at a big group and then a small subgroup inside of there is what we're looking at. Okay, so Venn diagrams do take different shapes depending on their attributes. So athletes, Olympians, you'll see that we go from general to specific. That's what we can make those things up of. So we can say if a person, let's say, is an Olympian. Almost forgot to spell that even though it's written on the paper. Comma, then he/she is an athlete. Okay, if a person is an Olympian, then he/she is an athlete. Alright, draw a Venn diagram of this situation for me. If you live in Chicago, then you live in Illinois, know that Chicago is a city in Illinois, okay, and draw that, give it, take a shot at drawing that Venn diagram. Okay, so that, and then a conditional statement you gotta take a shot at in the front, or a counterexample you gotta take a shot at in the front. Okay, alright, let's talk about converses, not the shoe. Okay, a converse is the converse of a conditional statement. Sorry, the converse of a conditional flips the hypothesis and conclusion. It flips. Okay. So symbolically, it's Q then P. Okay, and it's still a conditional statement, but what it does is that we change where the hypothesis and conclusion go. Okay, so let's look at a couple examples here. It says, write the converse of each conditional, determine the truth value of each statement. So here's our conditional statement. If x equals 9, then x plus 3 equals 12. Okay, and so our converse would be if, so we're going to switch the hypothesis and conclusion, if, now changing this because this is our Q originally, this is our P, we're going to flip those for the converse. If x plus 3 equals 12, then x equals 9. Alright, so then we can say what's the truth value of our original conditional statement? If x equals 9, then x plus 3 equals 12. Seems to be true. That's a true statement. Okay, what's our truth value of our new converse? If x plus 3 equals 12, then x equals 9. Okay, that is true as well. So no matter whether the order of the hypothesis and the conclusion, that conditional statement will be true. Okay. Alright, so we'll try this next one. It says, if you travel legally from the U.S. to Kenya, then you have a passport. That's our conditional statement. Okay. Our hypothesis, you travel legally from U.S. to Kenya. Hypothesis, you have a passport. Conclusion, we're going to flip those for our converse. If you have a passport, comma, then you travel legally from U.S. to Kenya. Alright, so running out of space there. Hopefully you guys got the gist of what I'm going to write. You can't read as I run off the edge. So the truth value of the conditional statement, if you travel legally from U.S. to Kenya, then you have a passport. Yeah, that's true. You gotta have one in order to do it legally. Flip it. If you have a passport, then you travel legally from U.S. to Kenya. You could, but that's not what it says, is you do travel that way. That's false. Got a passport, never gone from U.S. to Kenya. Okay? I would do it legally if I did, but since I didn't do that. That's a false. I could show myself as a counterexample. I have a passport, never gone legally from U.S. to Kenya. Okay. All right. Last conditional statement here. It says if a squared equals 25, then a equals 5. Our converse says, okay, again we're switching to ifs and thens. If a equals 5, then a squared equals 25. Alright, so the truth value of the conditional statement is actually false. Okay, because a could equal -5. Again, it's really important for us to provide those counterexamples when we're saying that something's false. So even if they don't ask us to provide it, that's where our thought should be. It's what's the counterexample to say if this is right or wrong. Alright, and then our truth value for the converse, if a equals 5, then a squared equals 25. Well, yeah, if a is 5, 5 squared is 25. That's true. Okay, so we've seen situations where our conditional was true and its converse was true. We've seen situations where our conditional was true and its converse was false. And we've seen a situation where our conditional was false and our converse was true. So you got to be able to analyze those independently. And then next time we talk, I believe, we'll look at some situations where our conditional statement and its converse were both true and what we can do with that. Okay, so get used to that terminology. Make sure you can identify the hypothesis and the conclusion of a conditional statement. Make sure you can write a conditional statement based off of a simple sentence, and then make sure you can write a converse by flipping the hypothesis and the conclusion. Alright, see you guys.